and have a screw coming from the back, which gives me the illusion of progress, which is a self-indulging toxic behavior, playing actual engineering roleplay. Who doesn't like a good roleplay? Full-on celebration mode, or solo drinking depression? Is it sad? Yes. Do I care? No. But we do like it sometimes, don't we? And I already pretend a little bit too much that I know what I'm doing, so I'm gonna pass on that one. Hello everyone, welcome to part number, I don't even remember, of me working on a 3D printed pen plotter robot. The goal of this project is to learn a bunch of things about engineering, developing a product from start to finish, and show you the progress to keep myself accountable. I get videos about this project at least weekly, so if you don't want to miss anything, I would highly suggest you to subscribe. Alright, so what is new since last time? First, let's talk a little bit about mechanical engineering. Last time we were faced with this problem where my Z-axis was coming into contact with some screws. The screws holding the pen collet together. I have the part right there. Exactly would be that one, this one in there, that would hold the servo motor in the middle. And so I did make a few adjustments, starting with, on the back, embedded nuts, which is a very funny term to me. But yeah, those essentially allow us to have a nut in there and have a screw coming from the back, oh jeez, to hold it together. I already have a bunch on the robot right now, and this is a very classic way of fastening parts together. For example, my Prusa printer, which is right there, uses a lot of those. And so this is one of the parts, and actually, the thing that didn't allow us to move properly were the head of the screws that was sticking out. So essentially what I did is just a little recess on this end effector joint that would essentially have the head of the screw just a little bit more inside. I did print those, and it does work very, very good. And like, it starts to feel that the mechanical part of the robot feels less and less flimsy and more like something that could actually work. So that's pretty nice. I would really like to work on another mechanism for the Z-axis though, because like, now that I say it, it's true that this part compared to the rest of the robot does feel out of place now that everything else is becoming more and more solid. Oh, and also, as you can see, like there is two colors, is because the brownish bone parts were printed in PLA and the rest is in PETG. So yeah, I just reprinted one of the arms again to be coherent with the rest of the robot. That's also a little change that happened. But yeah, mechanically speaking, there you go. Next, electronically, I did tell you about KiCad, a software I will use to make the PCB design of the robot. And I already started to tinker around, but as you can see, nothing too cute at the moment. I'm still trying to learn a few things about how all of this works. Works, I'm gonna go with works. The difference between symbol and footprint, installing different libraries, and so on and so forth. But still some progress. The software is downloaded at least, which gives me the illusion of progress, which is a self-indulging toxic behavior, but we do like it sometimes, don't we? But yeah, electrically, there you go, tinkering around KiCad, learning a new software, and yeah, playing actual engineering roleplay. Who doesn't like a good roleplay? Now for the good news. The very, very good news. As you know, we talked about that in the last video. Again, I would highly suggest you to go watch it. I had this issue in the communication between my Python API and the firmware of my robot that I tried to explain using these two fantastic drawings that each and every one of you can understand without any problems. Yeah. Anyway, so to make a long story short, in the previous video I went into the details of what that happens, but every time I sent a line of information to my robot, it took some time before it was processed and essentially had close to a 1 second delay between every single movement. And I had a couple of ideas of how to modify the logic in hopes that that would happen. I tried this logic and exactly the same thing happened. And so I was like, there is for sure something that doesn't work in there. So to transmit information from my PC to the ESP32 that is on the robot, I use serial communication through the USB port. And inside of that, the serial communication uses UART, which is in communication engineering, a very classic way of communicating packets. I will not go into the details of how that works, because first of all, it's fucking boring, a tad technical, and I already pretend a little bit too much that I know what I'm doing, so I'm gonna pass on that one. And so before going into how that works specifically on this board, I thought to myself that the problem was that the data that the ESP32 receives just takes, yeah, a little bit of time to be processed. Those are little characters that take some amount of bytes to be sent, and those bytes that are just sent like bits by bits need to be interpreted to be sent back again to the ESP32 with a string. This is all logic and it obviously takes time. And while reading this, I learned obviously about baud rate, which is like the number of bits you can send per second. And yeah, it shouldn't take that long. Like, it's less than a millisecond to send one of my lines. And so I thought about many different ways I could go around this problem. Maybe caching that information somewhere else. I went deep into how the data buffer works on the ESP32, trying to read on different forums about what to do and how to do it correctly, using interrupts, threads, and all that kind of stuff, until I read a little bit of something. I was on this forum and I read this little line right there. Try changing the timeout. Timeout. And on the actual documentation that I always read. Always. And apparently, by default, the serial communication using Arduino has a timeout variable that you can access right there with set timeout. That is, by default, 1,000 milliseconds. And if, like me, you have a gigantic ego and brain, you know that this means 1 second. For what? For peanuts, for shits. This is just a security interrupt to be sure that the data arrive. There's like 100 milliseconds for a little tiny line that arrives from a PC. That sounds a little bit too much. So what if, in my code, what if I simply change it to 2 milliseconds? You know, just to see what happens. And after 3 weeks of tinkering around, not knowing why that was, asking a bunch of questions, did that work? Yes, it did. A little one-liner. So you are back to the classic software engineering problems where when this type of shit happens, you don't know where to sit between full-on celebration mode or solo drinking depression. But in any case, we found a solution, and now we seem to have a reliable communication between the Python API and the robot. And is that something to be happy about? I sure hope so. And that's the thing that made me the most happy this week. Is it sad? Yes. Do I care? No. And so for software, this is what I did. Now what I'm working on would be the actual Python API. That's not true. I still have some things to work on the firmware, because for the moment, the only thing I receive is the step count of the two motors. I also need to account for the z-axis, which would only be a Boolean, by the way. It would just be pen on the paper or off the paper. That's all. But yeah, still need to integrate that. In any case, for the Python API, I will need to create a sort of like little library to be able to process informations a little bit easier. A function like move end effector to a new position, take pen on, take pen off. I think that would be it, which would already be a lot, by the way. But yeah, I need to do something like this. And also not forgetting that this is an ESP32, so we do have wireless communication with Wi-Fi, for example. So I don't know, create something to let my viewers react, Twitter, I don't know. We could do a lot of shit right there. We could do some stuff, for sure. So yeah, all of these ideas, all of these plans, this is cute and everything, but now we just need to work on it. Recently, I've seen more and more people tune up to the channel, which is pretty nice. By the way, welcome. I do love to see the interactions we have in the comments, people giving advice, opinions, which is something that tech boys apparently love to do for some whatever reason. But in any case, this is pretty nice. Very stoked to still work on this project. Don't hesitate to like, subscribe, do whatever you want to edge that sweet YouTube algorithm. I think that's enough yapping around for me. Wishing you a glorious rest of your day, and I see you soon on the internet. Bye-bye, everyone.